See, in this slide we will discuss the type 2 types, that is windows diagram showing the directions, duration and intensity. It's a type 2. See, in this diagram these are the some summarized points. From the wind data table, it is observed that the percentage of time during which is wind velocity is lesser than 6 km per hour. Workouts 100 minus 88 from the this representation graph, it equals to 12. This period is called as the calm period and does not influence the operations of landing and takeoff because of the low wind velocity. Thus, the wind velocity below 6 km per hour have no effect to the fixing of orientations of a runway. Thus, the wind velocity below 6 km per hour have no effects on the fixing the orientations of a runway. The concentric circles with the radii corresponding to 6, 25 and 50 and 80 km per hour to some scale are drawn. Thus, each circle represents the wind velocity to some scale. Strating the centers of the concentric circles, the 16 radial directions are shown on the outer circle. The middle points of 16 occurs on the outermost concentric circles are marked and then given the cardinal directions components like north, 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 east, northeast, east, northeast and east, etc. The recorded durations of wind and expressed as percentage as shown for each cardinal directions. It may be noted that the cardinal directions and the centrals to sector. A transparent rectangular template or paper strip is taken. Its length should be slightly greater than the diameter of the windrows diagrams and its width should be greater than the twice the allowable crosswind component, that is 25 km per hour. The scale for crosswind component should be the same as that of the concentric circles of wind rose diagram. Along the center of the length of its templates, a line marked corresponding to the directions of runway. Two parallel lines, one either sides of the center lines, is drawn at a distance equal to the allowable cross wind components, that is 25 km per hour from the center line. In the other words, two parallel lines are 50 km per hour away from each other. The wind roll diagram fixed in a positions on drawing board. As hole is drilled to a center line of the templates and it is placed on the wind arrows diagrams such that it center lines lies over the center of the wind arrows diagrams. In the positions, the templates is fixed by passing through the center of so that the templates can be rotate about the pin axis. The templates is rotated is planed along the particle directions in the positions of template duration of 6 to 25, 25 to 60, 25 to 50 and 50 to 80 kilometers per hour. Wind are the cardinal directions north, north, northeast, northeast, etc. laying between the two extreme parallel lines marked on the templates. The sum of all these directions expressed as percentage and it gives a total wind coverage for the directions. Runway length, it is the length of runway under the following assumed conditions: airport altitude at the sea levels, temperatures at the airport standard 15 degrees centigrade, runway labeled in the longitudinal directions, no wind blowing on a runway, aircraft is loaded to its full landing carrying capacity, and rotate temperatures standards, corrections for elevations and temperature for gradient. The basic run, this is very important because maximum time they will ask in video exams, correction for elevations, temperature and gradient. The basic runway length as discussed earlier for the mean sea level directions, elevations having the standard atmospheric conditions, necessary corrections and therefore they are applied for any change in the elevations, temperature, gradient for the actual site conditions. Correction for elevation, as the elevation increases the air density reduces, this is in turn reduces to lift on the wings of the aircraft and aircraft requires greater ground speed before it can be rise into air. To achieve greater speed, a longer length of runway required. ICAO recommended that basic runway length should be the increase at the rate of 7% per 300 meter. Rise in elevation above the mean sea level. So corrections for temperature, this rise in airport references temperature has the same effect as that of the increase in the elevation. Airport references temperature is defined as the monthly mean ranged daily temperature for the hottest months of the years plus one third of the difference of the temperature TA, and the monthly mean maximum temperature Tm for the same month of the year. Thus, airport is referenced as temperatures. ICO recommended that the basic runway length after the having been corrected for elevation should be further increased rate of 1% for every 1% centigrade rise of airport references temperature above the standard atmospheric temperature at the elevation. Check for total corrections for the elevation plus temperature. See, ICO further accommodate that if the total corrections for elevation plus temperature exceeded 35% of the basic runway length, these corrections should be then further checked by the conducting specific studies at the site of the model test. Correction for gradient. A stiffer gradient results in a greater consumptions of energy, as such long length runway required attain the desired ground speed. ICO does not recommend any specific corrections for the gradient. FAA recommended that the runway length after having been corrected for elevation and temperature should be further increased the rate of 20% for every 1% effective gradient. Effect gradient is defined as the maximum difference in elevation between the highest and the lowest points of the runway divided by the total length of runway. Basic elements of runway: structural pavements, shoulders, runway strips, blast pad, runway and safety areas, stowaway, clearway. Structural permanent, it is the paved area whose length and width designed to ensure the safe operating surface. It supports the airport load. Should the shoulders are the adjacent to the structural pavements which are designed rises erosions due to the joint blast and the accommodations of maintenance equipments and patrol. Runway strips, it includes the structural pavements, shoulders and area that is cleared and graded. The area should be capable of supporting fire, crash rescues and snow removal equipment. Blast pad, the blast pad is an area designed to prevent erosions of surface adjacent to the ends of the runway, which is subjected to repeated jet blasts, and to minimize the excuse ground maintenance, the area of either paved and planted turf. Runway geometric design, factors considered to the geometric designs of runway: runway length, runway width of length of this safety area, transverse gradients, longitudinals and effective gradients.